Hi, and welcome to my channel. Today's video is a discussion of specialty lighting LEDs used in model railroading. I talk about them in my book, and what I thought I would do is do a review of several commercially available specialty lighting LEDs and LED circuits. The first one up is going to be a random light circuit made by East Coast Circuits. Hope you enjoy this video, and let's get to it. Okay, as I mentioned before, this is first in a series of videos on specialty LED circuits for model railroading. The first one is East Coast Circuits, random light circuit number 301. These are three pictures of the particular circuit board in discussion here. The first one is as I purchased at a train show. The second one is a photo from the East Coast Circuits website. And the third one is a photo from a dealer website for the same circuit board. They're pretty much the same. The difference between them is that on mine, some of the components are standing up on end, resistors and diodes, as well as the photo from East Coast Circuits. The one from the dealer shows the components, diodes, and resistors lying down flat against the board. The actual number of circuits are about the same. Circuitry components are the same, but in this case, the one by East Coast looks like they are using a different chip that's surface mounted as opposed to plug-in chips on the two end photos here. The description of the circuit board or the circuit is that it's supposed to simulate people going in and out of homes and buildings with lights turning on and off to show that a person or persons have entered the room and are leaving the room. They mentioned timing of the lights or the LEDs is from 5 to 45 seconds, and we'll see what that means in the next slide. So the circuit as purchased from the train show indicates that this is random light circuit 301, which is the East Coast Circuits number, but it also shows a number 8200 New Jersey International. And I think what happened was New Jersey International was one of the distributors of the circuit that was designed by East Coast Circuits. The price I paid was $16 for it. The circuit is powered from AC or DC, and it says here that it draws 100 milliamps, which I did a test on to determine if that was true. Solid state design, 6 LEDs per circuit. You can have up to 6 LEDs. 3-volt output, has built-in resistors, so you don't need to add any external resistors. Obviously, it handles multiple LEDs, and it has built-in pins for future add-ins. And again, it's for use with LEDs only. So here are the specifications I found online. The input is 9 to 12 volts, and in several places, although it can use AC or DC, it mentions that you should not use more than 12 volts maximum, or you could damage the circuit. Small footprint, draws, according to this spec, 26 milliamps. Solid state design, again 6 LEDs per circuit, and it has built-in pins for future add-ons. I interpreted that to mean you could in the future add on things to it, but it really means the company may have plans for those 3 pins to do additional add-ons, which have not been implemented yet. The MSRP is $25. As I mentioned, I paid $16 for it. What I got might have been an earlier version. Okay, the wiring instructions on the web look like this. Now, the items you see, or the wires you see that are highlighted in yellow, were not on my instruction sheet that came with the product. So it made it a little bit more difficult to figure out what was going on. It mentions or diagrams a C here for common, but then it has R minus R, Y and Y, and G and G. So this may have been used for a signal light on a model railroad, or a traffic light, or something of that such, where red, yellow, and green were, red, yellow, and green were identified. But the new wiring instructions have these additional pieces of information which are helpful. It also mentions that they recommend using a surface-mounted device or 3mm LEDs where possible. I'm not sure why. The size makes a big difference. And you need to make all connections to the circuit prior to applying power. And it says it will draw approximately 26 milliamps under a full load here as well. So this is a video of my actual test, which was 10 minutes long. This video is speeded up 8 times normal speed. And these are some of the test results. First, I measured the current at 12 volts DC. And the current was anywhere from 7.5 milliamps with no LEDs up to 24 milliamps with 4 LEDs. I never saw 5 LEDs on at one time. And number 6 output, which is this one here, was bad. I played around with different LEDs. I tested the LED. It was good, but it was just dead. Output number 6 never came on. I called the factory, and they asked me to send it back to them for analysis. As far as one LED here, number 5, it only came on once in 10 minutes. So it was off at 7 minutes, and in the entire 10-minute test, it only came on once. Some LEDs stayed on 2 to 3 minutes. And what they meant by that spec of 5 to 45 seconds I talked about earlier is that the average time between a change in any of the 6 LEDs turning on or off was 20 to 30 seconds. So that was within the spec. I'm still a little curious about one thing, and that is why this one LED only came on once in 10 minutes. I'm hoping to get some answers on that. The board does have a somewhat narrow voltage range of 9 to 12 volts, but it can accept either AC or DC. So let's look at a summary of what I found out and what I recommend for this circuit. The instructions could have been better to avoid confusion. Again, instead of labeling outputs R, R minus, Y, and G, use numbers 1 through 6. Label the common lead on both sides of the board with plus LED common on the diagram. Explain that the 5 to 45 second spec refers to any change in the lighting of the 6 LEDs, which means any LED going on or off. And that seemed to be verified in this test. The factory is in Rhode Island. It was responsive and asked for the defected unit to be returned to troubleshoot. Assuming that the defect was an unusual occurrence, the circuit is a reasonable approach for a simple random lighting circuit at a street price of $15. Again, I think if you're okay with one LED of them coming on maybe 4 or 5 minutes, or maybe even once every 4 or 5 or 6 minutes, then it should be fine. Okay, that's it for this video. There'll be another one soon on specialty LEDs. Please like and subscribe, and consider becoming a member of the channel for perks such as early access to videos, exclusive videos, and documentation and updates. Thanks for watching.